right. Hi, everyone. Thank you so much for taking time out of your busy schedule today to attend the Tooling Challenge, Manufacturing Tool Management for NX Made Easy. My name is Diana Dietrich. I am the Marketing Specialist here at Swoosh Technologies, and I will be your moderator for this session. Just a brief on Swoosh. We are a partner of Siemens PLM Software, headquartered in St. Louis, Missouri, and dedicated to delivering software, training, and services in NX Design and Manufacturing, Team Center, and Solid Edge. Our goal is to help companies and individuals excel greater and realize their maximum potential in leveraging Siemens PLM products. Our presenter today is PLM Solution Consultant Steve Schnelker. Steve's expertise in the manufacturing industry has spawned over 3 decades. He began his career as a manufacturing engineer at Boeing in 1984. He later worked as a design and manufacturing software developer at Siemens PLM, overseeing and providing insight on software product development, management, and marketing of NX applications and processes. Today, his focus is assisting and introducing manufacturers to product lifecycle management strategies and showing how companies can deliver their products more quickly and efficiently. Also presenting today is Business Development Manager Mike Mediota of Siemens PLM. Mike began his career with Siemens PLM software 15 years ago as an applications engineer for Technomatics Technologies for their tolerance analysis and CMM programming products. He has been involved with supporting many of the Siemens PLM products within aerospace and defense, automotive, and high-tech industries around the world. In his current role, he supports customer and business initiatives and focuses on aligning product development strategy for the part manufacturing suite of products, including Part Planner, MRL, Shop Floor Connect, and NX CMM. Our focus is helping you understand how a single, searchable, and graphically accurate data repository can help you manage your manufacturing tooling more effectively. We notice that companies are struggling in managing their cutting tools, associated components, and assemblies. Alongside extra costs due to duplication, time that's lost by searching endlessly for correct tooling and having to find the documentation for tooling setup sheets can put a huge damper on keeping everything flowing effectively. During today's webinar, Steve will be discussing how the Siemens Manufacturing Resource Library, also known as MRL, can help you accelerate tool assembly development, eliminate duplication of effort, and reduce inventory costs by reducing SKUs. Mike will then be giving us a demonstration of the Manufacturing Resource Library system. Following Mike's demonstration, Steve will further discuss managing your manufacturing plan and how it will benefit you to do so. If you have any questions during the presentation, please don't hesitate to add them into your questions box located in your GoToWebinar panel. Steve and Mike will be answering your questions during our Q&A portion taking place right after the presentation. All right, Steve, take it away.
Thank you, Diana. As Diana mentioned, we're going to be looking at the Manufacturing Resource Library, or MRL, which has been being developed by Siemens over the last several years. And I like to define it, as Diana pointed out, as a single, searchable, and graphically accurate data repository for all of your manufacturing tooling. And I think you'll all agree that amounts to a lot of different SKUs that have to be purchased in inventory. You know, who needs it? Well, the NC programmer needs it to both define their programs by defining tools and tool assemblies. They also use it to verify their center-line source code as well as for G-code simulation. The tool setter requires the specification to build the tool assembly that can be used by the machinist, and the machinist requires it to accurately load the tool changer. Finally, purchasing requires it to understand what they have to purchase in inventory. The Manufacturing Resource Library is a database, and it sits in the middle of the application. It manages all the cutters, holders, collets, inserts, probes, and fixtures that you guys use today on the shop floor. Next, we think of it as a tool classification. If you look on the right there, you can see a nice graphical representation of how you can quickly drill down to the components that you need to add to your tool assemblies and build your tool assemblies. And connection rules allow you to quickly build the 3D tool assembly, which it can be used both in the shop documentation as well as for G-code simulation. The MRL is based on a number of tool classes Currently there's over 300 tool component classes, and there's over 70 tool assembly classes. Additionally, the user can add classifications on the fly as they need them. If you look here, here's a number of the different tool classes that are available today. One thing you'll notice from Mike's presentation is that it's a very graphical and easy to use user interface. If you look on the left, there's that classification hierarchy that we talked about earlier that allows you to drill down and quickly find those components that you need to create assemblies. The middle pane looks at the attribute screen, which allows you to quickly search. If you know you need a specific cutter of some diameter, of some corner radius, you can add a few attributes in there and do a search and quickly come up with what you're looking for. In the upper right, you'll see schematic drawings, and these schematic drawings will make sure that you have exactly the tool that you're looking for. And finally, lower right corner, the 3D tool assembly model that in turn gets used in the shop for documentation as well as for source code verification and for G-code simulation. Why would I want to use the Manufacturing Resource Library? A major task of all NC programmers is to define the tools they will use in their NC programs. If I give 5 different programmers the same part to program, I'll end up with 5 different programs and probably 5 different sets of tools. These tools equate to SKUs, and those SKUs cost money to both purchase and maintain. MRL, on the other hand, allows programmers to standardize on the tools they use and reduce the numbers of SKUs that are required. Additionally, it reduces tool definition redundancy, so I'm not having all my programmers out there defining tools. Instead, they'll just be using tools that are already defined. If you look a bit at the architecture and the roles, there's really 2 roles. There's a tool library administrator. He's responsible for creating tool assemblies, classifying the components. And then there's the NC programmer. The NC programmer utilizes these tools and tool assemblies that are available in their programs that they develop. From a licensing perspective, everybody requires a Team Center author license to utilize the product. They also require the NX embedded client. For those of you not familiar with the embedded client, it's basically an interface that allows you to run Team Center from within NX. If you have some of the older NX mock CAM bundles, they already have embedded client in it. If you have some of the newer NX mock CAM bundles, that would be an additional cost. The tool library administrator requires really the only MRL specific piece of software, and that enables him to do that classification work, and all the building the tool assemblies and so forth. He also requires Viz Professional, which is what we also refer to as the rich Team Center client. All of this is built on top of Team Center, as I mentioned, and can be used either with the Microsoft SQL database or the Oracle database. MRL can be deployed in 2 ways. One way you can deploy it is you can have a local physical server, and with the application all running locally, or we can implement it such that that server is up on the cloud, and your applications are running locally and they're accessing the information on the cloud if you don't want to go through the extra expense of purchasing the physical hardware and software required to run the implementation. That's the next slide. We talk about how do I populate my MRL database. Well, there's really 2 portions of the MRL database. There's the data attributes that you can think of: diameter, cut length, corner radius, tool material. And then there's also the 3D graphical tool geometry. Siemens, over the last several years, has been working with all the major tool vendors to develop the generic tool catalog. GTC is a generic structure similar to IGES as a standard, or DEMA standard, or a STEP standard. It's a standard format so that the tool manufacturers can put all of their tools in this format such that MRL can in turn pull that database in. Siemens is continuing to work with the major vendors, and they're making progress. However, at this time, the vendors haven't provided their tooling in the format required to pull into MRL. With that in mind, Swoosh Technologies has developed some utilities that allow you to create and import component geometry and attributes from the NX ASCII tool databases. If you're at all familiar with the ASCII tool databases, and if you're in NX and you're developing a program, anytime you define a cutter to be used in one of your programs, it gets put out into this ASCII tool database or holder database. What we have done is develop part families for each of the major cutter types and for the holder types, such that we can, it's a two-step process. One, we go through and take your tool database, populate our part families to create all the different tooling components, and we also, there's a PLM XML import utility for MRL such that we can read your ASCII tool database and bring in all that attribute data into your database. So with that, I'd like to turn it over to Mike, and Mike is going to do a demonstration of MRL.
Thanks, Steve. I'm going to go ahead and talk you through a little quick demo on MRL. We're going to start with here, this is the main Team Center window. This is my Team Center. This is really a starting point for entry into Team Center. And MRL is a module within Team Center that's built up of classification. What classification really is a collection of all of the things that you want to save and store and reuse in any manufacturing operation. So we have classes for things like fixtures, tooling fixtures, standoffs, screws, strap clamps, that sort of thing. We have robots, templates, and a number of different things. But we're going to focus for MRL on cutting tools. And so we break down our MRL structure into two main areas for cutting tools: assemblies and components. Now, the way to think about this is that your components are going to be your individual pieces to make up a cutting tool. So they're going to be your individual mills, perhaps your inserts, if you're running inserted tooling. It could be your tool holders, all of the parts that you're going to grab and physically use in your tool room to build up your cutting tools. So we have places that store pretty much any kind of structure for any kind of cutting tool you might need, whether it's returning, milling, grinding. All of those exist here. So we're going to focus in this case just on milling, and I want to look at indexable mills. So if I go here, I can stand on a class, I can select it and say this is where I'm interested. I can go ahead and do a quick search, and what it's going to do is find all of the tools. You can see here that it's already showing there's 6 in here. It's going to show all of the tools that are cutters that are classified here. Go to table view, and let's just look real quickly. Let's look at, say, this guy here. We can look at, in the properties view for this particular tool, the properties that are created for this tool. So we can see all of these property values, these attribute values, are based on the ISO 13399 standards. So those are industry standard nomenclature for defining a cutting tool. Over on the right-hand side, we've got a class image showing us what the attribute values mean. So if you look at this shortcut over here, the acronym, you can go over here to see what value that represents on the tool. In the lower right corner, I've got a 3D view of my tool. I can zoom and pan and make the screen larger, but I can see graphically what does this individual tool look like. And all of these values here are actually values we could search on. So if I knew I wanted to go search and see how many of a particular diameter tool I had in my library, I could do that. I can search these values. So what we do is we build up a collection of individual components, and then we're going to create tool assemblies for those. So in our case, a tool assembly is going to be, it's going to be an end mill, it's going to be the inserts that go in the end mill, and it's going to be the tool holder that's going to fit in the machine. So in this case, I know I have a request to go build an indexable 25mm end mill, and put it in a tool holder, and then send that out to my NC programmer. So let's go through that now. So I'm going to switch over to the Resource Manager application. I'm going to go ahead and give myself a little bit of real estate here. I'm going to say I'm going to create a new resource. So what I'm doing is I'm telling Team Center, I'm telling MRL that I want to create a new item in the database. It's going to be a tool. I'm going to assign it a unique identifier number that's checked out of the database, so I know I can always go search on this number and find my tool. I'm also going to give it a name, so a friendly name that I can see. So I'm going to say this is, let's call this end mill 25D, and then say OK. Now it's going to reserve this item in the database for me and bring me to the window where I can start building up the tool. On the left-hand side, this is the bill of materials line where I'm going to build up the tool. And on the right-hand side, it's going to be where I can view the properties or look at the graphics for it. So the next thing I want to do is I want to tell it, okay, where do I want to save this tool? So again, I select the classification route, and this is the same structure we saw just a moment ago, but now I'm going to go dive down and say I'm going to create this, and I want it to be stored in the assemblies area. So I'll choose assemblies, milling. In this case, I'm going to create an end mill, and I'm going to create an indexable end mill. So I choose this class, say select, that dialog goes away, and now it's going to update the top of the header here with the class that I've chosen. It's also going to pull the attribute data out of that class. So I know it's going to start filling in these values as it grabs it from the 3D model from the database entries. So now we'll go back over to the left-hand side, and let's start building up our tool. Next thing I want to do is I want to add a classified component, which means I want to go search my database and go find a tool that I'm looking for. In this case, I already knew that I wanted to be in the end mills. So let's go look in the end mills, and let's go to the properties view, and let's go back to the beginning here. Let's take this and do a search. It's given me all of the tools that are in the end mills, and I can go look at my table view. Then I can see for the end mills, I've got 6 end mills, and I'm going to go and select my 25 millimeter end mill here. I can turn on the viewer. I can view that particular one if I wanted to. You'd get a graphically look, see, was this the guy I wanted to find? And it is. So I say OK. What it's going to do now, it's going to start to build up my bill of materials on the left-hand side. So now it's brought in my end mill, and it's given it, you can see the name of the tool. It's brought in some information about the coordinate systems applied to it. But these lower 2 nodes here, these are what we call the guided component search. And what this is an indication of building up the tool both graphically and geometrically. So this red icon represents a junction where I can add something to the tool towards the workpiece. So in this case, this is going to be the inserts for the this connections for the inserts, and the blue component, which is the plug. This is going to represent going up towards the machine spindle. So first thing I want to do is let me turn on my graphical viewer, and I can show you what this looks like. So turn on the graphical viewer, enable the viewing, and you can see here's my tool again. And when I stand on these, I can see it's going to highlight here where my sockets are, and this is for the inserts. And let's go ahead and say right-click on this. I can say guided component search, and I'm going to go query the database for inserts which fit this particular socket. So the database already knows what the size of the socket is. It knows of all of the inserts in my database, which ones will fit. And I have 2 that'll fit. They're probably 2 different grades of inserts, but they're both the same geometry that'll fit in that particular socket. I select the one I want, say OK. And we can see when this loads in over on the right-hand side, it's now brought in my 2 inserts and placed them where they belong on the tool itself. So we're building up this bill of materials, which is really representing the actual tool that we're going to send to the shop floor to work with. Likewise, I want to go ahead and make the connection up to the machine spindle. So I'll right mouse button on the blue plug and say guided component search again. And now it's going to look at the connection of the diameter of the tool and also what type of holders I've got in the database. And I've got two holders that will hold this diameter tool. And so I can say, OK, I want to select this guy here, say OK. And now it's going to add this to my bill of materials. Bring it in, let's turn on the viewing again. So we add the tool holder, and it brings it in, it positions it properly based on the mount junctions from the tool and the tool holder. And now we've got a fully complete bill of materials. What I want to do, though, is I want to go look at my classification properties. And so I'll stand on the top of the tree here. Now, what we're going to want to tell, one last thing to tell Team Center is where we want to go ahead and bring in the attribute values from. So we need to stand on the lowest level and say any attribute values that exist from the insert up, I want to go ahead and propagate those to the top of the tool. So if I'm searching at the tool line itself, I can see what the insert size is and any properties that are associated to it. Go ahead and save the tool to my database. And then the final step here is to go ahead and generate the NX graphics and assembly file. So I'll click on this. Brings up a dialog asking us if we want to go ahead and update and create graphics for cutting and non-cutting geometry and your spin geometry. This is again useful for ISV and if your tool collision and gouge analysis. Set the junctions and write the attributes. So we'll say OK. In the background, it's going to go ahead and run NX. It's going to generate the tool assembly based on the components. So we're going to have an individual NX component for each insert, for the tool holder, and it completed. So let's go ahead, and now this tool has been fully saved into the MRL database, and I've finished my job as the tool administrator. Now let's go into the role of an NC programmer. Let's find this tool and go use it in the program. So I'll close MRL. We're going to start as the NC programmer role. I've got an NX CAM program that I've already started to work on. I need to go ahead and update one of my tool paths with a new tool. So I'm going into the tool path, and let's say I want to go ahead and search for my tool. I can go retrieve the tool from the library. And at this point, I'm going to switch over to look at the NMILS indexable and go find my new tool. This dialog here is going to query the MRL database. So you can see it's going to give me a graphical view of what some of the attributes are that I can filter and search on. They give me a lot more attributes than I have in a typical NX-CAM ASCII database. And all of these are values that I can use to filter and refine my results. So let's go ahead and count the matches. I've got 3 tools I can choose from. Pull in my new tool, say OK, and it's going to go ahead and update my my program with the new tool coming out of the MRL database. So here I want to go ahead and say let's go ahead and update my tool path. Again, it's going to update with the new. Let's give it just a depth of say 5. I'm going to update my tool path with the new tool, and now we've brought the tool in to the NX CAM session, and I can go ahead and do things like use it for simulation and verification with the new 3D model. So let's go see real quick what that looks like. So we'll go into see the new tool path. Let's go and simulate. We're going to load IS&V. We're going to run the simulation of this shown in the tool. So let's go to toolpath simulate, run. You can see here it's brought in the new fully parameterized NMIL with my spinning geometry has been defined when I did the auto assembly create function from MRL. The last thing I want to do is go ahead and take this and add this to my shop documentation. So I'm in the shop docs. I can go into my tool list and say OK. And then I'm just standing on the one program we're using here, and it's going to bring in my tool information, tool diameter. The values again are pulling it out of the MRL database for use in NX-CAM, my tool path. And then the last thing is go ahead and post my program and send it off to the NC machine. That completes the demo, Steve.
Thank you, Mike. During the demo, we got a number of questions from the folks out there that we'd like to see if they can get answers to. David Mai asked, will this MRL work with UGNX alone or with Team Center? And the next one's really similar, I think about the same. From Ryan Weiss, can MRL be used with an NX native environment? Do you think you could answer those two, Mike?
Sure, Steve. So good questions, guys. MRL is designed to be the tooling database that lives in Team Center, but how you access it from the NX side of things, really you have 2 options. If you run what we call like a full MRL, when you're running like I'm running here, where my NX session is connected to Team Center, I'm saving my NC file, my shop docs, everything I'm working in here in my NX CAM session is being saved to Team Center. That's what I call a full MRL environment. We also offer what we call MRL Connect. What MRL Connect is really just you still have Team Center for MRL, so your tooling admin will log into Team Center, into MRL to go ahead and create new tools, to work on the components and build up as tooling assemblies. But the guys that are doing the NC programming are going to run NX CAM or just NX in a native mode, and in that case, they're really not going to have a Team Center client installed. But whenever we configure NX, so whenever they go and search for a tool, it's going to bring up the tool dialog that I showed in the demo, where it's just going to go search for the tool in Team Center. But all of the work they do, and so the creation of the NC toolpaths and the creation of the shop docs, gets saved the same way they were before because it's still native. So it's going to get saved to their local file system, or however they're managing their NC programs. So you do have, both an option for someone that's running a full NX managed mode and NX native. Good question.
This next question's from Mark Schulz. He's wondering, he understands that MRI works both with inch and metric, but what happens to the thread data when you switch back and forth?
Okay, another good question. So MRL, you're right, will work in both inch and metric mode, and the way that you have to kind of think about how to use MRL in, say, mixed units mode is that the MRL dialogues allow you to display in either inch or metric or both if you're in a mixed units mode. But when you create a tool, you're going to want to create the tool in the units that you actually have the physical tool. So, for example, if you were going to create, say, a half-inch end mill, you want to create that as a half-inch end mill. But when you're in MRL, you can switch the dialog to show you what the value is in inches or what the value is in millimeters. But you're not going to actually change the size of the geometry. You're just going to say display me the diameter in inches, display the diameter in millimeters. So when you send that tool to your NC program, you're not going to change the units. If you bring in an inch tool into, for example, a metric setup, it's still going to be an inch tool, but you're going to see the display in metric. But however, if you are creating a tool that is a native metric tool, so it's a 6 millimeter end mill, you're going to want to create that as a 6 millimeter end mill in MRL so the units of the tool match the physical tool you're going to use on the shop floor. Hope that answers your question.
One more question from Bernie Giles, and really it's a general question. As we discussed, all the tool vendors haven't got their data in a form we can read it yet into the generic tool catalog format. Do you have any idea, the progress that Sandvik, ASCII, and Kennametal have made and when they might have something available for us?
Sure. This is one that we get a lot of interest in, a lot of questions around. So the real thing, the takeaway for bringing the tool catalogs is that you need the tools to come from the tool vendor in what we'd say is an ISO 13399 and GTC standard. So ISO 13399 is really the standard that defines what the attributes are with the names of each of the individual, the values you're looking at, say shank diameter and flute length, for example. And what the GTC component of that is the information that MRL uses to take the tool and use it for MRL use. So GTC is going to define where the mount junctions are. It's going to define basically the physical attributes, and it's going to relate the physical to the numerical attributes for the tool. So for the tooling vendors, Kennametal, ASCII, and Sandvik and others, is they are really actively working with us, working with the Siemens development team to make sure that they're getting catalogs that can come into MRL in GTC-friendly format. I'd say that the number one thing that we're requesting our customers to do is to make the request to let your tooling vendors know that you want the 3D models to come in GTC-friendly format, and they're all aware of it, and they're working with us to make sure that they're providing it. And in some cases, we even have customers that are, when they make a tooling request, they make a tooling purchase order from their vendor, they're saying, send me the tool and the GTC-friendly catalog files to go along with it.
Well, thank you very much, and that wraps up the questions. What I wanted to talk about now is, now that I've implemented Team Center, what else can I do? I work with a lot of what I would call job shops, meaning they aren't responsible for developing product. They build to order, basically. This could be aerospace, could be automotive, could be, oil field. But then I always try to talk to them about Team Center, and they'd say, that's a product data management system. We don't make product data, so why would I want something like that? If I've implemented MRL, as we just discussed, I've put in the whole infrastructure required to manage other things. And the one I like to manage from a job shop perspective is the manufacturing plan. So as you look at this slide, we've got product design, as most of you probably aren't responsible for that. But that comes into you in the form of a digital product definition into your manufacturing engineers. And then they're the ones that are defining the manufacturing plan, and they're in turn giving that manufacturing plan over to the shop so that it can be executed. Let me try to come up with a definition for the manufacturing plan. It's different for every company, but these are some of the things that I believe all of them have in them. It includes all the information that need a specific revision of a specific part or assembly. And that it could include the digital product definition. It could have an operations list, the bill of material, work instructions for each operation. It could have NC programs, CMM programs, robot programs. It could have setup sheets. It could have the tool list. It could have inspection and test instructions. And again, every company does things different, and that may vary. But basically, it's a lot of digital information that makes up that plan. Here's a view of a shop. I've never seen two shops that do it exactly the same. On the left, it's defining the manufacturing plan, and on the right, it's executing the manufacturing plan. One thing I've noticed with a successful shop, whatever process they come up with, they really do a good job of getting that right the first time. Where I often run into problems is what happens if there's a design change. Let me give you an example of this. I'm visiting with a shop floor foreman. I always ask the question, what are the 3 things that you could improve on, or what are your 3 biggest issues that you have today? And each of them almost undoubtedly are going to tell me, I want to reduce my setup time for setting up my machines. So the shop foreman and I went down the shop. He's got about a dozen machines. All of them are running but 2 which were being set up. So we walked over the machines that were being set up, and I started asking questions. As we drilled down further, we found out that a design change that came through, and the program needed to be changed to match the design change, and it wasn't caught till it got to the shop floor. So then we went to the second machine that was in setup. Similarly, the guy was kind of twiddling his thumbs. However, this time he's doing finishing machining on a casting, and the program was just fine, but the castings were coming in different, so he had to actually change the holding fixture. And that's what caused the setup increase. And the point of managing your manufacturing plan is you're going to get visibility to these types of things before they hit the shop floor. I've got a number of statistics here from the Gartner Group. Some are from different manufacturing rags and so forth, to kind of point out why you might want to manage your manufacturing plan. The first one, 79% of the companies have 2 or more manufacturing data repositories, and 25% have up to 15. 30% of people's time is spent searching for relevant information. 60% of the CEOs want to do a better job capturing and understanding information so that they can make better and swifter business decisions. And finally, only a third of the CFOs believe that needed information is available, accurate, or easy to use. If I had to boil it down to 3 reasons why you'd want to manage your manufacturing plan, you're going to spend a lot less time searching and more time producing. You're going to make better, more educated business decisions, and you're going to improve shop accuracy, compliance, and traceability. Well, thank you very much, and that wraps up the questions, and it wraps up our webcast for the day.
Okay, thank you.